Welcome to the deep dive. Today we're diving into the world of design patterns in software development. We've got a great presentation on the topic, and we're going to break it down. We're going to explain why these patterns matter, even if you're not like a coding expert.
Yeah, definitely. Think of design patterns like they're almost like time-tested solutions to those problems, those annoying problems that just keep coming up over and over again in software development.
Oh, I see. So it's like instead of starting from scratch every time you hit a roadblock, you can just kind of pull out this blueprint that's been proven to work, right?
Yeah, exactly.
Yeah.
And it's really interesting because the whole idea is based on recognizing, these types of problems and realizing that a lot of them can be tackled using similar approaches.
So it's not just about memorizing a million different solutions. It's more about understanding the underlying patterns and then figuring out how to kind of adapt them.
Exactly. And there's this book, it's kind of legendary in the field. It's called Design Patterns, Elements of Reusable Object-Oriented Software. It's often called the Gang of Four book.
Okay, Gang of Four book. I mean, that sounds a little intimidating. Is that like a secret society of programmers or something?
Haha, not quite. But it did revolutionize how we think about software design. Their book really focuses on object-oriented programming and lays out these patterns with actual implementations in C++.
So it's not just like theoretical stuff. It gets down into the nitty-gritty of coding.
Yeah, absolutely. So for example, imagine you're building an e-commerce website and you have to figure out a way to manage those shopping carts. Instead of creating something completely new, you could use the strategy pattern.
Okay, strategy pattern. I'm all ears. How does that work?
Well, so with the strategy pattern, it lets you define like a whole family of algorithms, like different shipping options, for example. You can encapsulate each of them into its own separate class. And then this way, you can swap out different shipping methods without having to mess up the rest of your code.
Well, that's smart. So if you need to add like overnight shipping or international delivery, you don't have to rewrite the entire shopping cart system.
Exactly. And that's really one of the best things about design patterns. They just give you this really nice, elegant way to build software that's flexible and that you can maintain.
So by using these patterns, you're essentially tapping into the knowledge of so many other developers who have probably faced these exact same challenges. So what are some of the biggest advantages of using this type of approach?
Well, I'd say first and foremost, you're reducing risk. Because these patterns have been tested and refined, like you said, by a large community of developers, for years, so you can feel pretty confident that they're going to be robust and reliable.
Yeah, that's a huge relief, especially when you're working on a big, complex project. Nobody wants to be stuck debugging terrible code at 3 a.m, right?
Absolutely. And on top of that, using these established patterns just naturally encourages code reuse, which in the long run just saves you so much time and effort. So instead of writing the same logic over and over again, you can just use these pre-built modules.
Right, it's all about working smarter, not harder.
Yeah.
What else?
I'd say another really key benefit is it really improves communication within development teams. Design patterns basically give you a shared vocabulary, a way for everyone to be on the same page when they're discussing software architecture.
So it's like having this common language that everyone can understand no matter what their specific background is with coding.
Exactly. It just makes everything so much smoother. The communication, it helps ensure that everybody is working towards the same goal. And well-structured code using these patterns is just so much easier to read and understand.
Oh yeah, that's like a godsend for anyone who's ever had to try to decipher someone else's code. Trust me, it can get messy.
Yeah, you're telling me. Readable code is just so important for collaboration, for maintenance, and for debugging.
Okay, this all sounds fantastic, but everything has its downsides, right? Like there must be some drawbacks to using design patterns, no?
Well, like with any tool, right? Like a powerful tool, design patterns have to be used wisely because if a pattern is misapplied or just misunderstood, it can actually make your code even more complex.
Yeah.
And harder to maintain.
So it's not just a matter of throwing patterns at every problem you run into. You have to actually know when and how to use them effectively.
Exactly. It takes a little bit of analysis to figure out which pattern is actually the best fit for a particular situation. And sometimes that analysis can take, a bit of time.
So there is a learning curve involved.
Yeah.
You have to put in some effort and really understand those nuances of different patterns before you can actually use them effectively.
Oh, for sure. But I really think that investment pays off in the long run because you end up with cleaner, more maintainable code.
Okay. So let's say we've done our research, right? And we've identified the right design pattern. How do we actually put it into practice? Like, what are the steps?
Well, I think the very first step is to really crystallize the problem you're dealing with. Like, what are the specific pain points that you're seeing in your code? And once you really clearly understand the problem, then you can start looking at different patterns. And you can see which one aligns the best with your problem. It's kind of like picking the right tool from your toolbox.
Yeah, you're not going to use a hammer to screw in a light bulb.
Exactly. Then you have to identify the participants. So those are the classes or objects that are going to be involved in implementing the pattern that you picked.
And you got to give them good names too, right? Like clear names so everyone understands what they're supposed to do.
Oh, yeah, absolutely. Those naming conventions are super important. And then after that comes the detailed work of actually implementing the pattern. So you're defining interfaces, you're creating classes, and you're writing methods. You're making it all come to life.
So you can't just copy and paste code. You really need to understand the ideas behind the pattern.
Right.
And then implement them correctly.
Exactly. Each pattern has a few key elements. First, you have the name, and that's so important for communication. And then you have the problem statement, which tells you when that pattern is useful.
So it's kind of like a label on a tool that tells you when you should use it.
Exactly. And then you have the structure. A lot of times you'll see that visualized in a UML diagram, and that shows the relationships between the different classes and objects.
Right, and that's where it gets a little intimidating for beginners, right? All those boxes and arrows.
Yeah, they can be a bit daunting at first, but they're incredibly helpful to visualize how everything fits together. And then there are those participants that we talked about. And usually you'll have a code example, too, to see how it all comes together.
That's great. Having a practical demonstration always helps to make things more clear. Is there anything else?
Yeah, so there's usually a section on usage, and that'll give you real-world examples of how you can use the pattern. And then there will be some discussion of how this pattern connects to other patterns, kind of the big picture stuff.
Right, because these patterns aren't isolated, right? They work together to solve complex problems.
Exactly. And that's what makes them so powerful. They let you build these sophisticated solutions by combining different patterns.
Now, we've been talking about design patterns in a broad sense, but it turns out there are actually different types of design patterns, right? Like categories within this whole world of patterns.
Oh, yeah, definitely. So we usually group design patterns into three main categories. We have creational patterns, structural patterns, and behavioral patterns. And each category deals with a different part of software design.
Okay, so let's break down those categories. First, we have creational patterns. What are those all about?
Well, creational patterns focus on object creation. You know how we make objects. And they provide ways to instantiate and configure objects in a way that's both flexible and efficient.
So instead of just making objects directly in your code every time, you're using these patterns to manage the creation process in a more controlled way.
Exactly. It lets you separate how you make the objects from how you actually use them, which means you can swap out different ways of making objects without changing the rest of your code.
Oh, so it's kind of like interchangeable parts in a machine? You can switch out one part with another as long as they both work the same way, and it doesn't break the whole machine.
That's a great analogy. It highlights one of the key advantages of creational patterns. They keep things loosely coupled, which makes your code easier to maintain and extend.
Now, I know our material mentioned that these creational patterns give you a lot of flexibility when you're creating objects. Could you maybe expand on that a bit?
Yeah, sure. So creational patterns give you control over who's creating the object, what kind of object it is, how you make it, and even when it's created.
Oh, so it's not just about making the object. It's about having this fine control over the entire process.
Absolutely. Imagine you're making a video game, and you need to create all sorts of different enemies. Instead of hard-coding the logic for creating each enemy in every part of your code, you could use the factory method pattern.
Okay, I think I'm starting to see the power of this. How would that work?
So with the factory method pattern, you would create a common interface for making enemies. And then you would have different specialized subclasses for each enemy type. And each subclass would be responsible for creating its own enemy object. So basically, you centralize the logic for creating objects and make it easier to add new enemy types in the future without having to change existing code.
So like if I wanted to add a super powerful boss enemy later on, I wouldn't have to go back and change a bunch of code all over the place.
Exactly. You would just make a new subclass for that boss enemy, and the rest of the code wouldn't even know about the new enemy type. It keeps everything nice and organized.
That makes a lot of sense. So what are some other cases where these creational patterns would come in handy?
Well, another really common situation is when you want to make sure there's only one instance of a particular object in your entire application. Like think about something like a database connection.
Right, so you wouldn't want different parts of your application trying to create their own separate database connections. That would probably cause a lot of errors, right?
Yeah, exactly. And the singleton pattern solves this problem. It makes sure there's only one database connection for the whole application.
So it's like a bouncer at a club, making sure there's not too many people inside.
Exactly. It prevents all those headaches. Okay, so we've talked about singleton and factory method. What about those other creational patterns you mentioned, like builder and prototype? When would you use those?
Okay, yeah, I was curious about those. When would you pull those out?
Well, the builder pattern really shines when you have objects that have a lot of different parts and configurations. Imagine building a house. You wouldn't just throw all the materials together randomly.
Yeah, no, you need a blueprint, right? Like some kind of step-by-step plan to put everything together the right way.
That's where the builder pattern comes in. It lets you break down that complicated construction process into smaller steps, so it's much easier to manage. And you could even have different builders for different house styles, like one for a modern house and one for a Victorian house.
Well, that's cool. So you could use the same building blocks, but arrange them differently to create different houses. That's pretty neat. What about the prototype pattern?
Prototype is a good choice when making new objects is really expensive. Like, let's say creating a new object takes a lot of processing power or memory.
So instead of starting from scratch each time, you can just copy an existing object.
Yeah, that's it. The prototype pattern lets you do just that. And copying an existing object is usually much faster than creating a brand new one.
I could definitely see how that would be useful in applications where performance is really important.
For sure. And keep in mind, these are just a few of the creational patterns that are out there. The key is to understand the ideas behind each pattern and choosing the right pattern for the specific problem that you're trying to solve.
It's like having a special set of tools just for creating objects. Now let's move on from creational patterns and talk about those other two categories that you mentioned, structural patterns and behavioral patterns. So first up, what are structural patterns all about?
Okay, so structural patterns are all about how we put together classes and objects to make bigger, more complex structures. But the goal is to still keep things flexible and easy to maintain.
So it's about managing that complexity as your software grows, right?
Exactly. A big theme with structural patterns is the idea of decoupling. That means making different parts of your code less dependent on each other.
We touched on decoupling a bit with the creational patterns as well. It seems like that's a pretty important idea in good software design.
Yeah, it is. When systems are loosely coupled, it means they're easier to change and extend, because a change in one part of the system is less likely to break other parts.
It's like making sure that if one part of your house needs repairs, you don't have to tear down the whole house to fix it.
Exactly. Now, let's look at some specific structural patterns. One that's pretty common is the adapter pattern.
Adapter pattern. What's that all about?
Imagine you have two different systems that need to work together, but their interfaces are incompatible. It's kind of like trying to plug an old game console into a new TV.
Oh yeah, you need an adapter to make the connections work, right?
That's exactly what the adapter pattern does in software. It provides a way to convert the interface of one class so that it matches the interface of another class. That way they can communicate.
So it's like a translator that allows two systems speaking different languages to understand each other.
You got it. The adapter pattern is super useful when you're trying to integrate existing components into new systems without rewriting the original code.
That makes sense. Now, the presentation also mentioned the bridge pattern. Is that similar to the adapter pattern?
The bridge pattern is a bit more nuanced. It's all about separating the abstract part of a class from its implementation so they can both change independently.
Okay, so can you give me like a real-world example of how you would use that?
Sure. Let's say you're building a music streaming app and you have different music players for different audio formats, like MP3, FLAC, and so on. Without the bridge pattern, you might end up with a separate class for each combination of player and format, and that would quickly become really hard to manage.
Right, you'd have so much redundant code.
Exactly. The bridge pattern solves this by separating the music player itself from the specific audio format. So you would have a music player class and an audio format class, and they can be combined in any way that you need.
So instead of having a class for every single possible combination, I can mix and match players and formats as needed.
Exactly. It's much more flexible. You can add new players or new formats without having to change the existing classes.
Pretty clever. Are there any other structural patterns that we should know about?
Definitely. The composite pattern is another one that pops up a lot. It's used to represent things that have a hierarchy, like a tree structure or a file system.
So if I'm building like a file manager application, the composite pattern would be a good fit.
Absolutely. It allows you to treat individual files and folders the same way as you treat groups of files and folders, which makes it much easier to work with complex structures like that.
That makes sense. And what about the decorator pattern? I've heard that one mentioned before, too.
Ah, the decorator pattern. So this one lets you add new functionality to an object dynamically without changing the original object's class. Imagine you're making a coffee ordering app. You could start with a basic coffee and then add things like milk, sugar, or whipped cream.
So you're adding these layers of functionality on top of the original object.
Precisely. It's a really nice way to add features without making your code a mess.
These patterns are starting to sound like Lego blocks. You can combine them in so many different ways to build all sorts of things.
That's a great way to think about it. And remember, we've only scratched the surface here. There are many more structural patterns out there. Each one offers a unique approach to organizing and structuring your code.
Awesome. Okay, we've covered creational and structural patterns. Now let's talk about that last category, behavioral patterns. What's the focus there?
All right, so behavioral patterns are all about communication and collaboration between different objects. They define how objects interact with each other, how they share responsibilities, and how behavior flows through the system.
It's like the social etiquette of the software world. How do these objects talk to each other and work together?
Exactly. One of the most famous behavioral patterns is the observer pattern.
Okay, observer pattern. Tell me more about that one.
Imagine you have an object that represents real-time stock prices. And then you have a bunch of other objects that need to know whenever those prices change.
So it's like a news feed where you can subscribe to certain stocks and get updates whenever something happens.
Precisely. The observer pattern lets those other objects subscribe to updates from the stock price object. And whenever the stock price changes, it notifies all of its subscribers so they can do whatever they need to do.
That makes a lot of sense. It's a really smart way to manage those dependencies and make sure everything stays in sync.
Exactly. And it's used a lot in graphical user interfaces too, because changes in one part of the interface often trigger updates in other parts.
Cool. Are there any other behavioral patterns you'd like to highlight?
Definitely. There's the strategy pattern, which we talked about a bit earlier with that e-commerce website example. It lets you define different algorithms and then swap them in and out as needed.
So instead of having one big, complicated algorithm, I can break it down into smaller pieces and choose which one to use at any given time.
Exactly. And that's super helpful when you have multiple ways to achieve the same goal and you need flexibility.
Like having different game plans for a football game. You choose the best one depending on the situation.
Exactly. Then there's the command pattern, which turns a request into an object. So you can do things like queue up requests, log them, or even undo them later.
It's like having a command center where you issue orders and track their progress.
Exactly. The command pattern is often used to separate the part of the code that makes the request from the part of the code that actually carries out the request.
Okay, so we've explored these three main categories of design patterns: creational, structural, and behavioral. And we've seen a few examples of patterns from each category. It's a lot to take in.
Yeah, it is. But the good news is you don't need to memorize every single pattern to start using them effectively. Just understanding the core principles can already make a big difference in your code.
That's good to hear. So as we wrap up part one of this deep dive, what's the most important thing you want our listener to remember about design patterns?
I'd say the key takeaway is that design patterns are about recognizing those problems that pop up over and over again in software, and then using proven solutions to make your code better. It's not just about the code itself, it's about thinking differently and working more efficiently.
That's a great point. They're like a blueprint for making better software. And in part two, we'll get even more hands-on and look at how some of these patterns work in the real world.
Yeah, sounds good. We'll dive deeper into some specific patterns and show you how they can be applied in practical situations.
All right, welcome back. So in part one, we kind of laid the groundwork, right? We talked about why design patterns are so important in software development. Now let's actually roll up our sleeves and get into the how. We're going to take a closer look at some specific patterns and see how they work in the real world.
Yeah, exactly. Remember those three main categories we talked about: creational, structural, and behavioral. We're going to pick a few interesting examples from each one and really show you how they solve these common problems in software design.
Sounds good. I'm ready to level up my design pattern skills. Where should we start?
Well, let's start with one of the classic creational patterns, the singleton. This one's all about making sure there's only one instance of a particular class in your whole application. Like imagine you're making a system to manage printer access in like a busy office setting.
Okay, I can see that. You got multiple people sending print jobs, and you don't want things to get all messed up with like multiple copies of the print queue manager running around.
Exactly, and that's where the singleton pattern comes in. It guarantees that you only have one print queue manager, and it prevents any conflicts. It keeps things running smoothly.
So the singleton is kind of like a traffic cop, right? It directs all the print jobs through a single organized channel.
Yeah, that's a great way to think about it. It's all about centralizing control and keeping things consistent.
That's pretty neat. So what about those cases where you have to deal with objects that are really complex to build, like a car or a house? We mentioned the builder pattern before. How does that come into play here?
Well, the builder pattern is really good at simplifying those complex object creations. It breaks the whole process down into smaller, more manageable steps. It's kind of like having a blueprint. So let's say you're designing a pizza ordering app.
Okay, pizza. I'm all ears.
So using the builder pattern, you could create different builders for different pizza types, right?
Yeah.
You could have a margarita builder, a pepperoni builder, a vegetarian builder, and so on. And each builder would handle the steps for making its own pizza.
So you're basically creating this standardized way of making pizzas, even with all the different variations people might want.
Precisely. And the best part is that you can add new pizza types really easily just by adding new builders. You don't have to change the core ordering system at all. It just makes the code so much more flexible and adaptable.
Plus, the customer gets exactly the pizza they want. It's a win-win.
For sure. Okay, so let's switch gears a bit and look at a structural pattern called the facade. Now imagine you're working with a system that has a lot of different parts, like maybe a home entertainment system with a TV, a Blu-ray player, a streaming device, and a surround sound system.
Oh yeah, I can already feel myself getting overwhelmed with all those different remotes and buttons.
Haha, yeah, and that's exactly where the facade pattern comes in. It basically provides one simple interface to interact with all those different parts. It hides all the complexity behind a single unified facade.
Oh, so it's like having one remote that can control everything instead
Yeah.
of juggling a bunch of different ones.
Yeah. Exactly. It just makes it so much easier to use those complex systems without needing to understand how everything works underneath.
That's definitely a relief. I like things simple. Okay, so what about those behavioral patterns? We talked about the observer pattern a little bit earlier. Can you give me a real-world example of how that one is used?
Of course. Think about a social media app like Facebook or Instagram that has a news feed. You know how you see updates from the people and pages that you follow?
Yeah, I see that all the time.
Well, that's a perfect example of the observer pattern in action. The people and pages that you follow are like the subjects, and you're the observer. So whenever one of those subjects posts something new, you get a notification in your newsfeed.
Oh, I see. So that's how it works. It's happening all the time without us even realizing it.
Yeah.
Pretty cool. So let's talk about another behavioral pattern. We mentioned the strategy pattern before when we were talking about the e-commerce example. Can you remind me how that one works again?
Sure. So the strategy pattern is great for those situations where you need to be able to switch between different algorithms or approaches at runtime. Like imagine you're building a navigation app and you want to give users multiple ways to find a route. Maybe they want the fastest route or the shortest route or maybe even the most scenic route.
Yeah, that makes sense. I use navigation apps all the time, and I love having those different options. It gives you a lot of control.
Absolutely. And with the strategy pattern, you can basically encapsulate each of those route calculation algorithms as a separate strategy, and then you can swap them in and out as needed.
So the user just picks which strategy they want to use, and the app automatically applies the correct algorithm to find the route.
Exactly. It makes the app super flexible and modular. You can easily add new route calculation strategies later on, or tweak the existing ones without messing up the main navigation logic.
Okay, I think I'm getting it.
Yeah.
It seems like all these patterns are really just clever solutions to those common problems that we face as developers.
That's a great way to think about it. And the more you learn about them, the more you'll see how they can work together. You can combine multiple patterns to build even more sophisticated and powerful solutions.
Now that's pretty cool. It's like having this whole new set of tools to solve problems in a more elegant way.
Exactly. And as you continue to learn and grow as a developer, these patterns will become like second nature to you.
Well, that's encouraging. And for our listener who's been listening to us talk about all these patterns, remember, you don't have to become a design pattern expert overnight. Just start by understanding those basic ideas and then try using them in your own projects as you come across those familiar challenges. It can really make a big difference in your code.
Absolutely. And in the final part of our deep dive, we'll give you some resources and tips that you can use to continue learning about this fascinating world of design patterns.
Welcome back to the deep dive. So we've made it to the final part of our exploration of design patterns. We've talked about why they're important, and we've even seen a few examples of them in action. Now, I think it's time to focus on you, the listener, and how you can actually use this knowledge in your own coding projects.
That's a great point. You know, these design patterns, they're not just these abstract ideas, right? They're tools, real tools that you can use to write better code, more efficient code. And the best way to learn them really is just to use them.
So it's not about just memorizing definitions. It's about getting hands-on and trying them out in your own code.
Exactly. Start by thinking about some of the problems that you've run into in your own coding projects, those common roadblocks, and then see if any of these design patterns that we've been talking about might be a good fit.
Right. It's about recognizing those patterns in the problems that you're facing and then grabbing the right tool for the job from your design pattern toolbox.
Precisely. Don't be afraid to play around a little bit. Experiment, Try implementing a few different patterns and see what happens. How does it change your code? Does it make it easier to read? Easier to maintain?
It's like trying on different hats to see which one looks the best on you. You might be surprised at how much of a difference the right pattern can make.
Absolutely. And as you work with these patterns more and more, you start to get a feel for which ones are best suited for different situations. It becomes more intuitive.
It's like learning a new language, right?
Yeah.
At first, it's all kind of jumbled. But with practice, it starts to feel natural.
Yeah, that's a great way to think about it. And just like with learning a language, the best way to learn is to immerse yourself. Read articles, study code, look at examples, and most importantly, try implementing them yourself in your own projects.
Now, are there any resources you would recommend for someone who really wants to dig deep into design patterns? Maybe some books or websites or even online communities where they can connect with other people who are interested in this stuff.
Oh yeah, tons. You know that Gang of Four book that we talked about? That's a really great place to start. It gives you that solid foundation, those core principles.
Right, the design patterns. Elements of reusable object-oriented software. That one. It's like a classic in the field.
Exactly. And, for people who are more visual learners, there are a bunch of great websites and tutorials out there. They'll break down these patterns using diagrams and examples, and some even have interactive exercises, which is really cool.
Perfect for visual learners.
Yeah.
What about online communities? Are there any forums or groups where people can kind of talk about design patterns and share their experiences?
Oh yeah, absolutely. There are loads of online communities specifically for software design and architecture. Developers hang out there, they talk about these patterns, they share tips and tricks, and they help each other solve problems. It's a great way to learn from others and get some feedback on your own code.
It's all about tapping into that collective wisdom of the developer community. All right, so as we wrap up this deep dive into the world of design patterns, is there any final piece of advice you would give to our listener who's ready to start using these patterns in their own work?
Yeah, I would say don't get overwhelmed. There are a lot of patterns out there. Don't try to learn them all at once. Just start with a few, understand the main ideas, and then gradually try incorporating them into your own projects. Remember, software development is a journey. It's all about continuous learning and getting better over time. And design patterns, they're a fantastic tool to have in your toolkit.
Well said. So to our listener, thank you so much for joining us on this deep dive. We hope you've learned some valuable things about design patterns and maybe even gotten a little inspired to try them out in your own code. Now go forth and build amazing things.